So AC is 50, therefore AE is half of that, which is 25. EB is 30, therefore DB will be 60. The idea we used here is for parallelograms, the diagonals bisect each other. For number 2, rectangles are parallelograms, and so the diagonals bisect each other. If xz is 10, then this will be 5 and 5. But also, the special property for rectangles is that the diagonals are congruent. So if diagonal xz is 10, then py is also 10. But how to find px, which is this side? Well, they told us that pz is 4. Therefore, in this right triangle, we don't know what its angle measures are, but we know it's a right triangle. And we know that a squared plus b squared equals c squared. So the hypotenuse squared is equal to the sum of the squares of the legs 4 and px. So 100 minus 16 is 84, and that equals px squared. So when we take the square root of both sides, px is the square root of 84. For simple radical form, 84 is 4 times 21, so the square root of 4 is 2. So 2 root 21. Not necessary, but that is simple radical form. Alright, let's take a look at the kite in number 3. Let's start with Qn. 15 units is from Q to N, which are these given expressions in blue added together. Alright, so 5y, and 4 and 1 is 5, is 15. So subtracting 5 from the left and the right, and dividing both sides by 5, y is 2. What about x? Well, the blue diagonal was clearly not bisected, but the other diagonal has been bisected, so x plus 3 equals 2x minus 1 in red. So we set those red expressions equal to each other and do the work, and we received x. So remember the properties of a kite. The diagonals are perpendicular. There's one pair of congruent opposite angles. They're the angles formed by the two different sides. 1 tick and 2 tick angle in between them. 1 tick and 2 tick. These non-congruent sides form this angle. Those two angles are congruent. The other opposite angles will not be congruent. And then that one diagonal that splits up those two congruent sides and splits up those two congruent sides, that one diagonal is also bisecting those angles of the kite, and it's also bisecting the other diagonal. And that's what we used here. This blue diagonal was bisecting the red diagonal. Alright, time for the isosceles trapezoid, whose legs must be congruent because it's isosceles. That means AD is congruent to BC. So, set them equal to each other, collect all of your terms on one side, we'll subtract 3x from the right, and we'll subtract 3x from the left. Now that everybody's equal to 0, we will try to factor. First times first gives us x squared, and last times last should be negative 40, and that's going to be 5 and an 8, plus 5 and minus 8. So that last times last is a negative 40, and negative 8x and positive 5x combine to give us negative 3x. So now we set each factor equal to 0 and solve. X plus 5 is 0, or x minus 8 is 0. So x is negative 5, or x is 8. And it can't be this one because the side then would be 3 times negative 5, which is negative 15. And we can't have a negative side length. That means x has to be 8, And therefore, the distance from B to C is 3 times 8, or 24. All right, for number 5, this is a rhombus, which means all of these sides are congruent. So we can set any two equal to each other, and it will be true. So let's pick the two that have the same letter, like the green and blue have x's. Again, it's a rhombus, so all these sides are the same. So we can set x minus 2 equal to 2x minus 30. And when we solve that, we have 28 is equal to x. So if x is 28, then what is y equal to? Well, if x is 28, that means this side length is 26. And if x is 28, 2 times 28 is 56, minus 30 is, again, 26, just as it was supposed to be. All these sides are the same. So if x is 28, and that makes these sides 26 and 26, all the sides are 26. And that's how we'll solve for y and z. Y plus 4 is 26. And z minus 5 is 26. Number 6, it's a rectangle. And they give us these. So label your picture, man. Label those expressions for sides EL, UK, etc. Now, if it's a rectangle, these opposite sides have to be congruent. So the blue equals the blue, and the red equals the red. Let's write that down. The blue is equal to the blue, and the red is equal to the red. Well, this is a system of equations, so your options are the substitution method or the elimination method. The way this one's set up, I would probably use the substitution method because step 1 is to get a letter by itself. Already done for you. This letter is by itself. So what is it equal to? Circle that. And then this is called the substitution method because we're going to substitute this into the other equation. Where? Wherever you see a y. So it's going to go right there. 10x plus 4 equals y plus 18. But y is 3x. Now we can solve this equation because it only has one variable. So we'll subtract 3x from both sides. We'll subtract 4 from both sides, divide both sides by 7, and x is equal to 2. And then just come full circle to the circle. Tells you exactly how to find y. Y is 3 times x. So if x is 2, y is 3 times 2, which is 6. Finally, what about the length of LU? That'll be 10 times x, which is 20, plus 4. All right, number 7, it's a parallelogram. So we know that the diagonals bisect each other. So if they tell us this diagonal has this half being 3x plus 2, then we know the other half is also 3x plus 2. How's that going to help us? Well, from D to B, which is the entire distance, from D to B, that's 23. So the 3x plus 2 plus itself, or two of them, is equal to 23. So this half plus that half is 23, or two of those is 23. So we have 6x plus 4 is 23 by distributing 2 times 3x and 2 times 2. We'll subtract 4 from the left side and subtract 4 from the right side. We'll divide the left side by 6 and the right side by 6. All right, we found x, 19/6, or 3 1/6. What about y? So look at the blue pieces. This rectangles, diagonals, have been bisecting each other. Rectangle, it's not a rectangle, this parallelograms, diagonals bisect each other. So that means the given 7y minus 2 must equal the given 5y plus 4. All right, we'll subtract 5y from the right, and we'll subtract 5y from the left. We will add 2 to this side, and we'll add 2 to that side. Then we'll divide both sides by 2, and we have y is equal to 3. Next, what about AC? Well, AC is the length of this blue diagonal. So if y is equal to 3, 5 times 3 is 15, plus 4 is 19. 19 and 19 is 38. And for EB, well, that's just this distance from E to B. It's 3x plus 2. Well, x is equal to 19/6. So 3 times 19/6 plus 2, well, that's equal to 19 halves, or 9.5, plus 2. So that would be 11.5. And that's how we do number 7. All right then, how about number 8 and number 9? For number 8, they give us the length of PR. That's a diagonal. And its length is 22 root 2. Well, QS is also a diagonal. And if it's a square, then the diagonals are congruent. So that means that QS is also 22 root 2. So the last question is, how long is PS? Well, this is a triangle. Since the original shape is a square, we know that the diagonals are perpendicular. The square's angles are all 90 degrees, and so these diagonals cut them all into 45-degree angles, and this yellow triangle, therefore, is a 45, 45, 90. This entire distance across was 22 root 2, and therefore half the distance across will just be 11 root 2. Do you remember the relationship in the special 45, 45, 90 triangle? When you know the leg, which in this case is 11 radical 2, you just multiply it by what number? You multiply that leg times the square root of 2. So the answer to the question, what is PS, is 11 root 2 times root 2, which is 11 times the square root of 4, which is 11 times 2, which is 22. All right, onward to number 9. Rhombuses, diagonals are perpendicular. So all of these angles are 90 degrees. And if 3x is equal to 90 degrees, then when we divide both sides by 3, we get x equals 30. And finally, number 10. Well, it's a square. And square is a rhombus, so all these diagonals are perpendicular. WY is the 10. And the diagonals bisect each other, so we know that the whole thing is 10 and each half is 5. And they want to know, how far is it from W to X? And also, what about from P to Z? Well, from P to Z, that's an easy one. It's a square, which is a rectangle, so the diagonals are equal. So if this is 10, then this is also 10. And so the halves will be 5. So from P to Z, we know that answer must be 5. The one that's going to require a little work is WX. WX is this dimension. There's more than one way to find this. One of them is to use this triangle in blue, which is a 45, 45, 90, whose hypotenuse is in yellow, which is 10. So recall that in the 45, 45, 90 special right triangle, to get from the large hypotenuse to the small leg, we don't multiply by root 2, we divide by root 2. And this simplifies to half of 10 root 2. There's our answer, But let's quickly look at another way to find Wx. What if we focus just on this little green triangle? It's a right triangle. And these sides are both 5, meaning it's isosceles. So once again, it's a 45, 45, 90. But in this case, we know the legs. So to get from the leg to the hypotenuse, it's leg times root 2. So leg times root 2. And we get the same answer. That concludes this worksheet. I hope this was helpful. See you in class. Oh, by the way, I just made this for you. This summarizes everything in chapter 6 that we've covered on quadrilaterals, which are 4-sided polygons. We talked first about parallelograms, and then some special parallelograms, the rectangle and the rhombus. Parallelograms had these properties. Rectangle and rhombus had those properties, and the square is both rectangle and rhombus. And then we talked about the kite, which had these properties, and the trapezoid, which had these properties.